To start things off, we've made a few modifications to the network configuration, mainly introducing a pump on both lines between the tanks and the final destinations. These pumps can be activated like a switch and, when turned on, allow material to pass through it at a designated rate. For this configuration, both pumps are configured to have a rate of 100 barrels per hour. Now let's jump into the scheduled events. So we'll access the schedule events menu from the events tab. And from here, we'll create a new schedule events folder. And we'll call this events folder. From here, we have the decision to create either a scheduled event or a stochastic event. We'll cover both in this tutorial, but let's start with the scheduled event first. In this example, we'll go through the case of limiting the flow rate of a few components in the system during a designated time interval. So, we'll name it limit rate, and we'll apply it to an object group. Now in this example, I've already created an object group that includes pump number 2 and outflow number 1. So we're going to select that object group. And for change type, we have 4 different options. We have fixed to, fixed by, relative to, and relative by. When selecting fixed to, you fix the new rate of flow to a designated flow rate of, in this case, barrels per hour. So initially, if we have the flow rate of 100 barrels per hour, and we want the new rate of flow to be 80 barrels per hour, we would simply put 80 barrels per hour in the rate change here. If we wanted to fix it to 80 barrels per hour in a different manner, we could use fixed by, and since the current state is 100 barrels per hour, we would input -20 to reach our target flow rate of 80 barrels per hour. Another way to do that would be to use the relative to change type. In this scenario, we start at 100 and our target is 80, so we would input 80% of the original flow rate. And the same applies to relative by, where if we start at 100, our target would be 80. So to do that, we would simply select -20%. So let's stick with the most direct approach. We'll select fixed to, and we'll simply put in our 80 barrels per hour right here. So before we move on to the time constraint, let's configure the frequency and the event duration of our limited rate. So the event duration, we want to limit our rate of pump 2 and outflow 1 to 80 barrels per hour, and we will say that this event will last for 6 hours. And this 6 hours of downtime will occur every 36 hours. Therefore, every day and a half, pump 2 and outflow 1 will have a reduced flow rate of 80 barrels per hour. Now, let's set up a time constraint, where we can either use model time from the start time of the simulation to a designated stop time of the simulation, or we can configure it by a calendar date. Since our model starts running on October 1st, 2019, let's have it start on October 2nd, 2019, and we'll have this limited rate fluctuation occur until October 9th. So we have a solid week of demonstration for this scheduled event. Now let's save and run our model. Now that we've loaded the model in the front page of the standalone engine, let's run the model. So now that we've began the model run, we start on October 1st. But as soon as October 2nd, 2019, at 0 hours occurs, pumps 2 and final destinations 1 will have a reduced rate of 80, right there. And as soon as we hit 6 hours of downtime, it'll return back to its original flow rate. This scheduled event is set to an interval of 36 hours, meaning that at 12 o'clock on October 3rd, it should occur one more time. And there it is, right at 12 o'clock, meaning that at 1800 hours, it'll return back to its original state. Now that we've configured a scheduled event, let's move on to the secondary event type, stochastic. In this example, we'll configure reoccurring random pump failures within a designated window of time. So to start off, let's rename it pump failure. And since we selected pump 2 for our scheduled event, let's select pump 1 for our stochastic event. Now in this example, we want to simulate a pump failure. The change type functions the exact same way as seen in the scheduled event. So we'll simply fix our rate change to 0 barrels per hour for the duration of the event. We'll configure the rest of the fields down below before returning to time constraint. The current life for the frequency setup is the hours that have passed since the last failure event. So, in this case, let's set it to 2 hours. So at the starting time of the simulation, a failure event would have occurred 2 hours prior. For the mean time between events, we have a variability type where we have access to a couple of different distributions, where we can either set a triangular, normal, or uniform distribution for the reoccurrence of our stochastic event. So let's stick with a normal distribution. So let's set our distribution so that we can expect a failure anytime between every 3 to 5 days. So a way to do that would be to set the mean time between events value to 4 days. So 96 hours. And set our deviation to 25% to encompass days 3 and 5. Now for the mean time of the event, we'll say that the pump shutdown will last for 12 hours with a deviation of 10%. Now we'll also set up a time constraint, so these failures will only occur within a certain window of time that the simulation will run. But in this case, instead of using calendar dates like we did for the scheduled event, let's use model time, where we only want these failures to occur in the first 30 days of the simulation. So that would be 720 hours. Now that we've configured our stochastic event, let's test it out in the standalone engine. So once we have our model loaded up on the front page, let's refresh all the changes that we made on the online platform. So, as we're running our model, you'll be able to see that our scheduled event of a limited flow rate for pump 2 and final destination 1 is still in effect. And now that it's day 3, we can expect a pump failure to occur any day now. So the first failure occurred on day 5 around 10 a.m. And this pump failure should last for 12 hours with a deviation of 10%. So let's run the model and see when the next failure occurs. So the second failure occurred on day 10 at 1700 hours. Let's see when the third hits. So it looks like I may have been a little slow on the draw, but we can see that the time interval between failures is not constant, and that this failure occurred sometime between day 13 and day 14. Now in this example, we have a designated time window that we're looking for a failure to occur on this piece of equipment, but realistically, you could implement your failure data that you've collected from the field and introduce it to the model to create a scenario where realistic failures occur within the model in order to get a more detailed simulation of your field operations.